Hello, my name is Andrew Seitz, and I manage a team of data scientists and data analysts at Snowflake. One of my team's primary stakeholders is our cloud finance team. Our cloud finance team's primary charter and responsibilities are the managing and optimization of our cloud spend among all the 3 public cloud providers that Snowflake's currently offered on. Today, I want to talk about a project we embarked upon around optimizing our reserved instance portfolio. And if that's not immediately apparent what a reserved instance portfolio is, don't worry. By the end of today's talk, you'll have a solid understanding of what reserved instances are and how you can actually use them to optimize your cloud spend. As all of you are probably familiar with, Snowflake is a cloud data warehouse that was architected from the ground up to be built for the cloud, so it's cloud native. At the center of Snowflake, and one of the key tenets of Snowflake, is the concept of the separation of storage from compute. So we have a centralized storage layer, and this is where actually all of your data within the Snowflake platform lives. And then surrounding the centralized storage layer are clusters of compute instances or resources that we call virtual warehouses. And these virtual warehouses are what are actually powering your queries, and these can be scaled up and down to any size to match whatever workloads you have. In addition, these virtual warehouses can also be run in parallel to handle any amount of concurrency that your organization might need. And they can all query the same centralized storage layer and the same data at the same time. Due to this, however, the primary cost to actually deliver the Snowflake service is these compute instances themselves. To give a sense of the scale that Snowflake's operating at, we consume millions of dollars annually in cloud spend. And therefore, if we make improvements of even a few percentage in our cloud spend, it will lead to massive dollar savings. Additionally, since Snowflake is a consumption-based business model, meaning our revenue is directly tied to the actual usage of the product, the usage of these compute instances in the virtual warehouses, our revenue, therefore, is directly proportional to our cloud spend. And our revenue more than tripled last year and is on pace to do something similar this year. So these quantities are growing rapidly. And to add to the complexity of this problem, we also, as I mentioned earlier, operate across all 3 major public cloud providers, Amazon, Azure, GCP, in multiple regions and availability zones. Each of these regions and availability zones have their own unique usage patterns and variable costs associated with them. So in order to operate at this scale, it requires a high level of automation. Today's talk is primarily going to be from the viewpoint of AWS or Amazon, and I'll use those interchangeably. However, these lessons are generally applicable across all 3 public cloud providers. I want to set the stage for today's talk by giving a brief introduction to cloud finance and what that means at Snowflake. I'd mentioned that the primary costs of the service are compute instances themselves, and these compute instances, also called virtual machines or EC2 instances on Amazon, come in many different sizes and shapes. Some of these are optimized for compute-heavy workloads needing large CPUs or some memory-intensive workloads that need a large amount of RAM. Amazon subdivides these into instance families and instance sizes. So here we have the general purpose A1 instance family and some of the many instance sizes that this comes in, medium, large, extra large. As we go up in instance size for each family, we get a corresponding increase in performance, whether that's in the number of CPUs in the machine or the amount of memory the machine has available to it. As we increase performance, we also get a corresponding increase in our hourly cost in order to run that instance. Amazon also provides a lot of flexibility in how you can choose to actually pay for these compute instances. And the general tenet is, as you increase your upfront commitment to Amazon in terms of how long you say you're going to actually pay for that instance, or how long you're actually going to use the instance for, the lower the hourly costs and the greater the discount you'll get in return. These discounts, or these forms of commitment, come in two primary flavors. The first are on-demand instances, and these are really the true promise of the cloud. You only pay for what you use, so the moment you turn on the instance, the moment you turn it off is what you're billed for. Additionally, in exchange for that flexibility, you also are going to pay the most expensive rates for these types of instances. The other form of primary commitment are reserved instances, which are an upfront commitment to Amazon, typically for a 1 to 3 year term for a specific instance family. And in exchange for that upfront commitment, you get huge discounts, up to 30 to 75%. However, the caveat with these reserved instances are they're use it or lose it. So if you don't actually use the instance for one of the hours on your term, you'll still end up paying for that instance. For each of the instance families that Snowflake buys reserved instance for, we have our own unique internal usage patterns. Some of these instances are running background services that are running 24/7, and they're very predictable. Others are spun up on demand to match our customers' workloads. As you can see pictured to the right, you can see what a typical customer's consumption pattern of Snowflake might look like, with some variability throughout the day to match their business needs. Behind the dark blue line, we can see what we'll actually provision in terms of instances to meet that customer demand. And then the most important thing here is this orange line. This orange line is our reserved instance coverage, or the number of reserved instances that we currently own. Anything above the orange line, we pay at the more expensive on-demand rates. And anything below the orange line, we pay at the cheaper reserved instance rates. We can also see that there's some white space underneath this orange line. And these are instances that we're paying for, but we're not actually using. The key concept of today's talk is really going to be focused around how do you effectively set this orange line so you minimize your upfront commitment to Amazon while also maximizing your cost savings. The consequences of setting this orange line too high or low is drastic. If we set it too high, we're going to be overcommitting and paying for a lot of servers that we're not actually using. And if we set it too low, we're going to be paying the more expensive on-demand rates, and our cloud spend is going to skyrocket. Now you might be asking yourself, this is a fairly meaty problem. Are there any solutions on the market that can solve this cloud spend management issue? There are SaaS applications like Cloudability and Cloud Health that do a great job at tackling this problem, and Snowflake actually started out on Cloudability. And we found that these are great for companies who are first getting started on their cloud journey, or maybe you're at a startup where you can't focus enough time or resources on this problem with headcount. However, we found that we needed the ability to explore and dive deeper into our cloud spend data sets, and we also needed the ability to join this data together with our own internal product and service data. Additionally, these SaaS applications charge at a percentage of your cloud spend, which we found at the rates that we were growing, the costs greatly outpaced the value that we were getting back. Each of the public cloud providers also provide a similar solution for free that are roughly at feature parity to these cloud applications. However, they have the same issues in that we can't join or explore these data sets deeper, and they also don't operate cross-cloud, which was a requirement for Snowflake. So where does this leave us? Existing solutions on the market were simply unable to operate at the scale and complexity that Snowflake needed and required, and the cost was greatly outpacing the value that they were providing back to us. So we needed a custom analytics solution to handle this problem. The solution we found was a combination of Snowflake and Looker. We can ingest all of our cloud billing data sets directly into Snowflake along with our product and service data, and then utilize Snowflake as our computation engine to run these calculations for the problem that I talked about earlier. And then we can layer Looker on top of Snowflake to serve as a real-time access layer for our cloud finance team to interact with these calculations and also to provide them real-time access to these data sets. Before we could get started on this problem, there were a couple of key data sets that we needed to actually ingest into Snowflake, into our internal data warehouse called Snowhouse, which is our internal implementation of Snowflake. And from the cloud provider side, there were three key data sets that we needed to ingest. The first was the cost and usage report, which contains hourly and instance level granularity of all of our cloud spend and usage for Amazon. Our reserved instance portfolio, which contains a historical time period or a historical look back at what reserved instances we owned at what periods of time and what that currently looks like. And then the pricing for the various cloud services, so we can understand in each region and for each instance type what the on-demand versus reserved instance rates look like. We also already ingest all of our product and service data directly into Snowhouse, and so we get that for free. So now I want to talk more specifically about how do we actually run the calculation to set that orange line for each of the regions and instance families that Snowflake uses. This is a tool we call a reserved instance planner, and it looks at some period of time and calculates what would have been the optimal level of reserved instance coverage in order to give us the greatest cost savings back. We split this up into really four main parts. First, we must bring all the historical data together into a single table for all those data sources I had talked about. We then run a linear optimization calculation on top of that table that we had brought all together. And this will spit out the optimal number of reserved instances for us to purchase. We then take this number and return it back to our business end users and provide them the ability to dive deeper into the recommendation to determine, did we actually make a good recommendation? Because there are some situations where we might make a recommendation to purchase reserved instances, but it actually isn't a good idea. And I'll talk about a few examples of those kind of situations later. So for the first step of really constructing the query and bringing all the data together into the same place, for the time period we selected for the calculation, we look at each hour AWS account, which is comparable to Snowflake region, and instance family, and look at what were the total instance hours that were consumed during that 1 hour. We think about things in terms of instance hours. So if you were running an EC2 instance for 30 minutes within an hour, that would be half of an instance hour. We then calculate the breakdown of what we spent on on-demand instances versus reserved instances. In this case, our reserved instance workload is constant because we only buy reserved instances at some weekly frequency. Additionally, we bring in the on-demand rates and the reserved instance rates for each of those time periods and instance family and account combinations. So once we have all of this data together in a single place, we run a linear optimization calculation where we look at some time period of historical usage, and then for each hour, we do a what-if analysis of if we had different levels of reserved instance coverage in that hour, what would our cost savings been in each of these scenarios? To bound this question, we must ask ourselves, well, first, what are the number of reserved instances we might want to purchase? At the lower bound, we would purchase zero additional reserved instances, and that would be what our current reserved instance coverage is. At the upper bound, we look at the time period that we're running the calculation for, and we find which hour had the most number of instance hours. So in this case, we currently own 10 reserved instances, and the max hours over the time period was 15. We then figure out the delta between those numbers, and those are going to be the hypothetical number of reserved instances we could purchase, so 0 through 5. We take this and calculate an effective number of reserved instance hours. So it's just the sum of our reserved instance hours plus the hypothetical reserved instance of purchase. And then we recalculate the cost in each of these scenarios. So we can see at the top line, it's going to be 10 reserved instance hours times the cheaper reserved instance rate, plus 5 on-demand hours times the more expensive on-demand rates. At the bottom, we have what we would consider perfect reserved instance coverage, where we would say we have 15 more expensive reserved instances times the 15 reserved instances times the cheaper reserved instance rate, and no on-demand instances. We then take and group by the hypothetical number of reserved instances, and we sum the cost across the entire time period that we're running this calculation. The hypothetical number of reserved instances with the lowest cost, so if we sort by our cost ascending, so whatever has the lowest cost, is what we actually make as the recommendation. So of all the scenarios, this one scenario had the lowest cost over this time period. So what does this actually look like in practice? So we take advantage of templated filters and filters to allow our business end users to be able to configure this query in real time, factoring in things like which region they want to run the calculation for, what time period they want to run the calculation for, whether they want to look at maybe 14 days in the past, or we can layer on some of our server forecasts and look at some historical and future time periods. Additionally, we offer configurations around purchasing options. So are they buying all upfront RIs or recurring RIs, depending on cash and things like that, and what contract length are you buying for? So are you buying 1 year or 3-year RIs? These all determine what kind of discounts you actually get in return. After they've inputted this information and they've actually run the query, it's going to spit out a recommendation for what we should have purchased and what would our cost savings been in each of these scenarios. And as I had mentioned earlier, we never blindly trust a recommendation. And so we provide our business end users the ability to dive deeper into this calculation in 2 ways. The first is what we call our usage curve. And this is very, very similar to that orange line that I had mentioned earlier, the visualization with the orange line. And it shows us what our instance usage over the time period that we selected for the calculation looks like, and then what was our reserved instance coverage for that time frame. A way we can use this to debug whether we had a good recommendation or a bad recommendation are if there were any visual anomalies in this data set. An example of one such anomaly might be when our engineering team runs a backfill on a large data set, or maybe is debugging a one-off issue. We can then use this to open a line of communication with our engineering team and determine, is this a one-off workload, or is this something that's actually going to be happening on a recurring basis? We can then use that conversation to decide, should we be purchasing reserved instances or should we not? Next, we have our savings curve. And our savings curve looks at the hypothetical number of reserved instances we could have purchased and what would have the cost savings had been in each of these scenarios. So this is really a visual output of the calculation that I talked about on the last slide. The recommendation we're making is actually the top of this parabola, where we're getting the most cost savings back. And so you can kind of see what that situation looks like over all the different scenarios. However, if we have a very, very flat savings curve, meaning for different levels of commitment, we get similar levels of discounting or cost savings, we might actually choose to forego some of the discount in order to have lower commitment. And that would be moving kind of to the left of that savings curve. So what was the impact back to the business? First and foremost, we saved 2 to 3% annually on our cloud spend by building our own solution and replacing Cloudability internally at Snowflake. which, as I mentioned earlier, led to huge dollar savings for the business. Additionally, we were also able to make improvements on this calculation. We would report bugs to Cloudability that we found, and it would sometimes take months or quarters for them to respond or fix the issue. And with an internal product, we're able to address all of these things within hours. Additionally, we're able to layer on some internal custom solutions like custom server forecasts and custom anomaly detection to actually handle some of the manual steps in this calculation that I had mentioned earlier. So we're working on automating as much of it away as possible. But the real value back to the business is we were able to build an internal and in-house expertise for this business-critical function at Snowflake, enabling us to make our service more effective and more efficient and cost-effective for our customers. This was just one of many projects that my team embarked upon with our cloud finance team, using both the combination of Snowflake and Looker. Thank you all for attending today, and I'm happy to answer any questions.